Green hydrogen is pivotal for global decarbonization, expected to contribute around 25% of CO2 reduction by 2050. India has set ambitious target to achieve net zero emission by 2070 and energy independence by 2047. So the country aims to generate 50% of its electricity from non-fossil fuel by 2030. Green hydrogen is crucial for decarbonizing hard-to-abate sector like steel, cement, and heavy transport, helping India become a global green product champion. Now, as we know that National Green Hydrogen Mission, especially launched in January 2023, and NGHM position India as a global hub for green hydrogen production, use, and export. So, production, use, and export, all the three components is under the agenda of NGHM. The mission targets a green hydrogen production capacity of at least 5 million metric ton per annum by 2030 and potential doubling to 10 million ton with export. Now, to support this electrolyzer capacity aims for 60 to 100 gigawatt backed by 125 gigawatt of renewable energy. So investment of around 100 billion US dollar and the creation of over 6 lakhs jobs are expected alongside an ambitious goal to reduce hydrogen cost to 1 US dollar per kilogram within a decade. So now coming to our next slide, which is about a green hydrogen production technologies, where it shows that electrolyzer will dominate future hydrogen production and there is no way out. Now it is expected to supply around 70% of global hydrogen by 2050. So we can imagine a huge growth of this production technology of hydrogen. Now, key technologies include alkaline water electrolyzer, uh, proton exchange membranes electrolyzer, anion exchange membranes, which offer a huge R&D promise, and solid oxide electrolyzer. Now, India is pushing innovations to reduce electricity consumption because electricity has a huge role. So we can say that India is pushing innovations to reduce electricity consumption, improve durability, and scale manufacturing of components with complementary pathway like biomass gasification under explorations. Now, our coming to the next slide about the challenges in hydrogen uh, 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 storages and transport. We can say that hydrogen is the lightest gas with unique hazards, wide inflammability, low ignition energy, and material compatibility challenge such as embrittlement, as these things are well known to everyone. As for the storage option ranges from high pressure composite tank to cryogenic liquid hydrogen for uses. Now pipelines remains the most efficient for long distance transport with blending in CNG lines proposed to cut the cost, and as we know that around 15-20% part can be blended with CNG. Now, additionally, underground storage in salt caverns and chemical carriers like ammonia are vital components of India's green ecosystem. Now, coming to the basically hydrogen safety framework in India, which is supposed to be very important as we know that safety is the fundamental to public and investor trust. So Indian regulatory bodies are developing a standard covering the entire hydrogen value chain, aligning with international norms. Currently, approval is limited to tanks at 350 bar, with guidelines for higher pressure under development, and process safety management practices incorporating hazard identification, risk assessment, and emergency planning are being already going to be implemented. So ongoing R&D focuses on material compatibility, human factors, and computational accident modeling also. So now coming to the India's hydrogen infrastructure growth, which involves coordinated effort from the government, policies, equipment manufacturer, EPC contractors, and end users. Testing infrastructure is expanding, though gaps remains that must be addressed to meet a standard. Financial incentives through program like SIGST encourage electrolyzer manufacturing and production. Also, workforce skill development and public awareness campaigns are essential to sustain momentum across the hydrogen value chain. Now, India is actively collaborating internationally with countries such as Germany, Japan, the US, UAE, and Australia. By 2030, India aims to export 12 million metric ton of hydrogen, with key demand from Japan and South Korea. The vision is to be a leader in green hydrogen production and use, boosting energy security and industrial decarbonization. Challenges include reaching cost parity with the grey hydrogen and expanding global electrolyzer manufacturing capacity.